Hello, everyone, and welcome. Thank you for joining the Oregon Housing and Community Services Multifamily Energy Program training on energy efficient multifamily building operations. This is Mecca Abraham speaking now. I'll be serving as the moderator for this webinar. And our presenter today is Nick Young from the Association for Energy Affordability, our training partner on the program. Go to the next slide, please. I just wanted to start off with a few housekeeping notes and instructions on how to use GoToWebinar. Today's webinar will be recorded and available on the program website within several days of this presentation. All attendees are currently in listen-only mode. If you'd like to ask a question, you can do so by asking a question in the chat box in the GoToWebinar panel. We'll do our best to answer questions in the order that they are received. And at the end of the training, we'll open up the audio line for questions. In order to participate at that discussion at that time, please enter your audio pin located in the center panel of your screen and raise your hand in the meeting panel and we can unmute you. Next, please. And as a reminder, this webinar is part of a series of trainings geared towards supporting current multifamily energy program participants and professionals. We will cover topics relevant to both existing buildings and new constructions. So we have one upcoming training after today. It's on health and safety on multifamily buildings on Thursday, October 25th at 12 p.m. So future trainings will be advertised on our newsletter and our website. So I'll pass it on to Nick Young to get started on this training.
All right, thanks, Mecca. Hi, everyone. Again, my name is Nick Young, and we've got a lot of content to get through today for the training. Actually, Mecca, before I jump in, how many folks are on the line currently or on the webinar?
Yeah, we have a couple of folks on right now.
Okay.
So you can get started.
Probably more will
yeah.
continue joining. All right, great. Yeah, so we're going to start with an overview of operations and maintenance in general, talk about energy management and how that can be integrated into O&M, go through basic concepts in building science, and then look at how those building science principles are actually applied to energy systems in buildings in terms of how we operate them and how we maintain them to maximize building performance. So starting with operations and maintenance. So we're dealing, the idea here is that when you're operating and maintaining a building, the building already exists. So you have, in some sense, limited options. You may want your wall to be better insulated, but you may not have that luxury, and you have to work with what you have. If it's as building operators, you're dealing with the building as it exists. As a developer, you may be working on projects where you're doing upgrades and you have the opportunity to make improvements, but building operators are working with what's there. So the key to energy efficient operations is to control or reduce waste. And it's important to understand that this is different than using less. If we want to use less energy for heating in the winter, we could just turn the thermostat down, right? That would be a way to use less. But what we want to do is we want to reduce waste. We don't want to ask people to be less comfortable in a building, but we want to find ways that we can reduce energy that is being wasted and isn't being put to good use. And to do this requires effective partnerships. We need to have ownership and management on board. Maintenance staff needs to be trained and understand how the systems work, and building occupants are another important component of these partnerships, because we can make things great, but if building occupants don't understand how they're supposed to work or are used to doing things one way and continue doing things like that with a different kind of system, you can have lower performing buildings or other sorts of problems. And so education along all these axes is really important. And if we're able to do that, there are a lot of benefits, starting with substantial energy savings, which is sort of a basic understood benefit. Energy efficiency yields energy savings, but that also gives us lower operating costs through our lowered utilities, as well as other improvements like longer equipment life. Lowers operating costs as well. We also should have no sacrifice of comfort or productivity. Again, the idea is to reduce waste. So do what you already want to do. Deliver the comfort and building services that the building is supposed to deliver more efficiently and more effectively. And all of this can help provide better information for making capital improvement decisions because we have better information about how our building is performing. So let's talk now about some basic types of maintenance. And the first type of maintenance that we'll discuss is reactive maintenance. Reactive maintenance basically means run the equipment until it fails. And this is an extremely popular form of maintenance. And if this were a classroom setting, I would ask folks why. So I guess I'll sort of throw it out to the group. Folks on the line, folks from TRC, does anyone have any thoughts as to why reactive maintenance might be popular? Feel free to type it in the chat box.
Well, we'll chime in. We don't have any comments in the chat box,
Sure.
But I imagine it's popular because you don't have to worry about planning for it and just get it done when it needs to be done.
Yeah, great. So reactive maintenance is popular because there is no thought necessary to reactive maintenance. You just keep on keeping on until it breaks, and then you deal with it. And people think that this is the lowest cost approach. But in fact, emergency repairs can be extremely costly. And also you can end up sort of in an emergency situation having to install equipment that's not very efficient because that's all that the local repair person or whoever's doing the repair has on hand. And so you may end up locking in lower performance for a long time. And so what we want to do is we want to avoid reactive maintenance and move toward a better form of maintenance, which is preventative maintenance. Preventative maintenance means doing things scheduled based on time or run time. So things like pump lubrication, or like a common preventative maintenance practice that folks are used to performing is changing filters, right? A system with an air handler that has a filter on it. Everyone's aware that you need to change the filter on a regular basis, and so people have that on a schedule. We change it every month, every 2 months, every 6 months, sort of depending on how the system is used. And so this is one step better than reactive maintenance. A step beyond preventative maintenance is actually predictive maintenance. And predictive maintenance is basically collecting information from the systems. Some systems will actually collect this diagnostic information themselves. And so the idea behind predictive maintenance is if it's almost broken, fix it. So instead of waiting for something to break, you wait for it to give you signs that it might be going to break soon, and then you fix it. So you're able to sort of predict when something might fail and ensure that it's repaired or replaced before that. So just as a wrap up on this slide, we want to avoid reactive maintenance when we can. Of course, situations are going to happen. You're going to have to react to things. If something breaks unexpectedly, you have to react to it, you have to fix it, and that's unavoidable. But what we want to do is we want to employ practices that enable us to move more in the direction toward the right, where we're doing preventative maintenance, predictive maintenance, so that we really minimize the occurrence of situations where all of a sudden something breaks and we weren't planning for it. And to do this, we need to have a plan, specifically a maintenance plan. And there are a few components of an effective maintenance plan. The first is a master equipment list. This equipment list will have nameplate information for all equipment, where it's located, the service it provides, as well as the operation and maintenance manuals for the equipment. We'll also need to have a preventative maintenance chart, or PM chart. This sometimes comes from the manuals for the equipment. It may, if anyone's ever read the entire car manual that comes with your car, it usually has a maintenance chart that says at this many miles you need to do this, and at this many miles you need to do that. And the same thing goes for major pieces of equipment. And so this will help us determine how frequently what maintenance needs to be performed. Maybe it's daily, weekly, biweekly, monthly, semi-annually, or annually. And from there, when work needs to happen, we need to have a preventative maintenance work order process that includes the task, the skill and tools requirements, and the estimated number of hours. Now, what form this maintenance plan takes will vary widely across organizations. So a large property management organization with dozens of buildings and tons of employees and lots of things going on, they may use an online platform that enables them to manage this centrally, to have everything sort of easily tracked. But that system may cost some money, but it makes sense for a larger organization to do this. For a small owner who owns and operates 2 or 3 buildings, maybe having a sophisticated online system isn't necessary, and they could do this in Excel or some other sort of some other digital platform. Other folks traditionally have done this on paper and used, physical charts and equipment lists. So it doesn't really matter what form this takes. The important thing is that we have this information and that it's organized so that we know what activities need to happen when to ensure that we're doing the preventative maintenance on the equipment that's going to really improve its useful life and reduce the chances of unexpected failures. So that's our maintenance plan. We also need to ensure that we have effective procurement policies. Because what we purchase and keep on hand is going to then be what ends up being put into our building for as needed replacements or repairs. I can't tell you how many times we've been into a building that maybe it's not, maybe it's a few years old, and we see lots of the original equipment or original, let's say, light fixtures or plumbing fixtures, and then here and there we see a different light fixture or a different plumbing fixture, and it's not as efficient as the ones that were installed originally. And we say, like, hey, what's going on here? And they say, well, it broke, the one that was there was an issue, or the tenant damaged it, or something happened, and we replaced it, and this is what we had on hand. And so ensuring that what you have on hand for as needed replacements or repairs is just as good, if not better, than what is already installed in the building will go a long way to ensuring that performance is maintained over time. So that's really important. Also, a big point of inflection for performance can be the unit turnover. So when units turn, what is our standard practice? What are the set of fixtures, be they light fixtures, be they plumbing fixtures? What are the maintenance and sort of cleaning practices that we undertake for unit turnovers? Are we removing furnaces and cleaning them? Are we just painting and turning it over as fast as we can? So ensuring that the practices, because the unit is empty, you have the opportunity to make sure that that you have everything right where you want it to be before it's occupied again, and then it becomes much more difficult to do any upgrades or repairs or other types of maintenance activities. So it's important to be thoughtful and be deliberate about what we're doing at unit turnover. So that's the basics of energy, of operations and maintenance in terms of your maintenance plan and procurement. Now let's talk about energy management. And energy management starts with energy accounting. To control energy costs, we have to start by identifying what are we paying for. So as the owner or property management organization for a multifamily building, the house meter or the house utilities may include electricity. Pretty much will always include some electricity. They may include fossil fuels like natural gas in some more remote locations, sometimes propane, water, and there are other upkeep costs like groundskeeping. Properties with large amounts of landscaping, groundskeeping expenses can be significant. So we need to know what services we're paying for, and then for each of them, how much are we consuming? So the most basic way to understand this is via the utility bills. a more in-depth and fine-grained way to understand how much you're consuming is using utility benchmarking. And I know benchmarking is not a sort of required component of this program, but it is something that it's beneficial for folks to do, and we'll see a little bit more on the next slide about benchmarking. So once we know what we're paying for and how much we're consuming for each of these utilities or end uses, we can know what our realistic savings opportunity really is. Because if someone comes around and tells me, hey, if you replace X piece of equipment, you're going to save 50% on, you're going to save 50%. It's like, okay, 50% of what? 50% of my heating bill, 50% of my water heating bill, maybe it's a pool pump, and so it's 50% of my like pool electricity usage for that end use. And so it's really important for us to know how much savings potential there is. We need to know how much we're using in the first place, because especially in very mild climates, saving 50% of a very small number is a very small number if you don't have much heating, or let's say you don't have any cooling at all, which a lot of coastal areas don't have any cooling. And so if somebody's offering you and telling you that install this piece of equipment, it's going to reduce your air conditioning by 50%, you're like, well, we don't have any air conditioning. So you have to know what your baseline is to be able to understand and to know if improvements are going to really, how beneficial they're going to be and which ones are going to be the most valuable for your property. Really target those end uses that are the biggest pieces of the pie so you can have the most impact. So to get a little bit more detail in terms of how much you're consuming, you need to understand your utility usage in more detail. And that can be done by disaggregating your baseload and then potentially doing the full benchmarking. So baseload disaggregation means separating your baseload energy usage from your seasonal energy usage. So baseload is energy usage that does not vary by season, such as ventilation, domestic hot water, lighting, and cooking. So to be totally accurate, domestic hot water does vary slightly by season. People take slightly longer, slightly hotter showers in the winter than they do in the summer, but people use hot water year-round. Lighting, it's darker in the winter, and so people have to turn on the lights slightly more, but it's not significant. Cooking is pretty constant year-round, except for a spike around the holidays. So, but for the most part, baseload is the energy that is constant. If you think of a sort of graph of what your energy usage looks like over the course of a year, there's going to be a sort of solid bar at the bottom that's just constant all the time. It's energy you're always going to use. And then you're going to see peaks and valleys with the seasons. And the seasonal energy usage is basically heating and cooling. Mecca, can you just let me know, like, what fraction of multifamily buildings in this program even have cooling?
We've actually been seeing more cooling now, especially being included in new construction projects. So I definitely think it's becoming more of a trend.
And how about for existing buildings?
That varies, usually not, because they're usually electric baseboards or cadet heaters, but tenants sometimes have window units installed on their own.
Got it. Yeah. Okay, cool. Yeah, so you'll see energy usage that's varying by season, and that's gonna be your essentially your heating and cooling. To really get a sense of where the opportunities are, particularly if you have a larger portfolio, the best way to do that is to use benchmarking. Benchmarking is a tool-based tracking of energy usage across multiple years or across an entire portfolio. And this enables you to use evidence-based targeting of buildings with the largest savings opportunities or operations and maintenance challenges. I'm not going to go into more detail than that on benchmarking. If you want more information about benchmarking, or you're curious about benchmarking your project as a part of this program, talk to the folks at the program, and they can help you out. So we'll take a quick break for any questions about energy management, operations and maintenance, those various types of maintenance, or the energy accounting.
Okay, thanks, Nick. So we do have a couple of questions, and just as a reminder for the attendees, if you have a question, you can enter it into the question box and we can answer it there. The first question we had is, who should be involved in developing the maintenance plan? Is it just the building operators that are doing the maintenance, or should other folks be involved?
That's a great question. I think it's best if it is a collaborative effort. So definitely the folks carrying out the maintenance need to be involved. But it's something that usually, for the way we've seen it done for larger organizations, is like a maintenance supervisor or sort of maintenance director for the whole organization will work with individual maintenance supervisors per property to develop a specific maintenance plan. So maybe you have a standard template and then you customize it per property to ensure that, okay, we have the relevant maintenance tasks for this property. And also you need to make sure that you're doing what you need to do for the different pieces of equipment. So you might have a service contract for some larger pieces of equipment where a service technician comes out regularly. So you might want to just check with them and make sure that their stuff is included on there, and you know, okay, we don't have to do this. Somebody else is going to be doing this maintenance task.
Okay, and then our other question is, during unit turnover, what equipment is recommended to check? Oftentimes we only have a few days at unit turnover.
Yeah, that's a great question. So things that are that can be replaced easily and quickly, and that can have a big impact. So things like water fixtures, ensuring that, you know, if the tenant has swapped out a shower head, that you put in your standard water efficient shower head. If they've swapped out a faucet aerator, that you ensure that you put in your, you know, building property standard, whatever your standard is. Hopefully it's water efficient, so that you don't sort of lock in whatever less efficient fixture the tenant may have modified. That's pretty common. And then often we see folks replacing light fixtures with more efficient ones. These days, a lot of folks are installing hardwired LED fixtures. It makes it easier for tenants because they probably aren't ever going to have to change one of those out, or if they do, maintenance can just come and swap it out. So it tends to be lighting, plumbing fixtures, as well as if you do have in-unit heating equipment, ensuring that it's cleaned. And if it's just electric baseboards, there's not a whole ton of maintenance to be done on those. But if you have ducted systems or other systems with that are moving more air around, then ensuring that those are cleaned and new filters are installed will go a long way.
Great. Well, that's all the questions we have right now.
Okay, perfect. So yeah, keep the questions coming. And if you have one that's super pressing, just type it in the box, and Mecca has full permission to interrupt me anytime if there's a question that would make sense to answer, you know, while I'm in the middle of the slide. So please type any questions you have into the chat box. So we're going to jump into building science. So what is building science? Building science is the study of the interaction between various materials, products, and systems used in building construction, the occupants of these buildings, and the environments in which they are located. So that was a bit of a word salad. But I think if you just sort of zoom out and look at the bold words on this slide, we have interactions between materials, products, and systems, as well as the occupants and the environment. So we have all these different things. We have the materials that our building is built out of. Like if you're sitting in a building, which most people probably are, unless you're lucky enough to be listening to this webinar outside. If you're sitting in a building, you can look around and you can see all the things that the building is made of, right? There's also the systems that are operating. So the heating system, the ventilation system, the lighting system. And then there are the people in the building. You are sitting in the building and you are affecting it in certain ways. You're turning things on and off. You're walking in and out of doors. You're opening windows. You are perspiring. You are breathing. You're adding heat to the space. And all of those interactions are affecting the building and affecting how energy moves around the building. And essentially, building science applies physics to understand how buildings operate and to solve building failures. So let's look at some fundamentals of building science. The first is that heat travels from high temperature to low temperature, or from hot to cold. So when you touch a burning hot pan, what you're feeling is you are feeling energy that is traveling from that hot pan to your less hot finger. The energy is moving from hot to cold. Second, the greater the temperature difference, the higher the rate of heat transfer, right? So you feel that very rapid heat transfer when you touch a very hot pan. If you touch a pan that is, let's say, 100 degrees relative to your skin that's like 98 degrees, you may not experience any heat transfer, or it might take you a few seconds to even notice, like, is this hot? Oh, okay, it's warm, right? Because the rate of heat transfer is affected by the temperature difference. Insulation reduces the rate of heat transfer. We all sort of intuitively know this because we know that when we wear a jacket outside when it's cold, we lose heat less quickly, right? Heat from our body radiates out into the environment more slowly, the thicker the insulation. And the same goes for our buildings. Air travels from areas of high pressure to areas of low pressure. So if when we do things that affect the pressure dynamics of an apartment or of a building, that's going to cause air to move, and air will find a way. Hot air rises. So frequently people say that heat rises. Heat doesn't actually rise. Heat, as we saw in the first bullet point, travels from high temperature to low temperature. Hot air, however, if you have a pocket of hot air, that hot air is less dense than the cold air, and so because it's less dense, it's going to rise. So hot air rises, but heat doesn't necessarily rise. Additionally, water goes from wet to dry. If you have an area with lots of moisture and it's surrounded by areas that are drier, that moisture is going to diffuse out. And the flow of that moisture or water is going to seek the path of least resistance. And this is something that we all sort of have intuitively experienced if we've ever been inside of a building with a leak, especially a leak in a ceiling, right? If there's a leak in a ceiling, there's a chance that if we open up the ceiling, the leak will be right above there. But there's also a good chance that the water is actually coming from somewhere else entirely, and then finding it's snaking its way via the path of least resistance and then coming out where we're seeing it. So flow, whether it's water, whether it's heat, whether it's air, will always seek the path of least resistance. And that's true regardless of what is flowing. So using these fundamentals of building science, we can start to think of a building as a system. And as we discussed a few slides ago, buildings have many connecting components. There are structural systems, there are mechanical systems, there are materials and assemblies, and there are occupants, right? We as occupants affect the buildings. And sometimes components that are very far away from each other can interact and have effects that are perhaps hard to understand or hard to suss out. And minor changes in one area of a building can lead to major consequences in another area. And so as building operators and as building maintenance professionals, you've all, I'm sure, experienced like a problem over here that was, once you figure it out, actually caused by something way over there. And the way that things move around in a building, that energy moves or that water moves, just because you see a problem here doesn't mean that it's caused by something here. It might have been caused by something way over there somewhere else. And so it's important to understand how all these interactions can affect a building in terms of the different components. So that was a lot on building science. So I just want to break real quick and see if there are any questions on the fundamentals of building science.
Okay, I will give it a minute. Don't have any questions currently.
Okay, well, I can keep going, and then if questions do pop up, just let me know.
Okay.
All right, great. So we're going to now start to take a look at the various energy systems in multifamily buildings and common operations and maintenance opportunities for those systems. This is just a preview of what we're going to be going through, and we'll start with the building envelope. Major components of the building envelope in terms of those that affect Building performance and energy efficiency are the air sealing or air tightness, the insulation, and then the windows. We're going to focus primarily on these first two, the air sealing and the insulation. For air sealing, when you're air sealing a building, and this presentation is focusing on existing buildings. A new building and in new construction, the way that you approach air sealing is from a design and sort of implementation standpoint, and ensuring that there's workmanship and there is testing of air tightness. The content that we're going to be talking through is you already have a building and you want to find leaks that may be there and fix them. The way that you do air sealing on a new construction project is slightly different, and you can do a much better job of it. It's less of a patching situation than it is like we need to be really thorough. So if you're dealing with an existing building and you want to start air sealing it, you generally want to start at the top of a building. We want to seal the bulkhead doors at the top of our stairways, any gaps around plumbing or flue chases, recessed lighting fixtures, roof wall junctions, as well as attic and utility accesses. So this is a bulkhead door. Does anyone see a sign that we might have a problem?
There's probably heat. It looks like right in front of the door on the ground, there may be heat leaking out because the snow is melted.
Yeah, bingo. So right here, we can see that the snow is melted, which means that warm air, we've spent all this energy to heat up the air inside the building to make it warm and comfortable for people. And then we're just letting that air come right back out of the underside of this door. This is extremely common at bulkhead doors. They are often very poorly sealed. And this is an example of the evidence you can see of that. So it's really critical that we weather strip and seal these doors. We also mentioned sealing around flue chases in attics. So here you can see an example of a flue that's coming up into an attic surrounded by insulation. And when you have an air gap like this, and especially in the wintertime, cold air can come in and hot air can come out. And that's not what you want, right? You want your building to be air sealed, and this is not it. You can also see the dirt around this opening, which means that the insulation is acting as an air filter, which is not designed to do. Insulation is not an effective air barrier, and so it will not stop airflow. Air will travel right through it, and in this case, the insulation is just getting really dirty from all the air that's passing by it. So we need to ensure that this is well sealed. We also want to seal our roof wall junctions. This is an example of a roof wall junction and someone sealing it with two-part foam. You can do this with all manner of products, but we want to ensure that all of our junctions between different materials are sealed. We also often we pay a lot of attention to weather stripping our doors, right? We do a great job of weather stripping doors. The doors are nice and sealed, and then we insulate our attic, and then we put an attic hatch in, and it's like barely a piece of wood that just sits there and can be super leaky. Attic hatches are notoriously leaky, and so we want to ensure that one, we have insulation on top of our attic hatch, but also that we're sealing around the framing, and if we can, have gaskets to ensure that we get a nice tight seal for that attic hatch, so we don't just have rampant air leakage coming through our attic hatch, which is super common. So that's an idea about what we need to seal at the top of the building. Now, we also need to seal kind of everywhere else in the building, because remember, air will find the path of least resistance. So just because you've sealed one area doesn't mean the air is not going to find a way in or out of the building somewhere else. So we also need to seal the bottom of the building. I'm just going to pop through these very quickly. At the bottom of the building, we often have pipes, cables, and other surface penetrations. Those can be very leaky. It's often a huge pipe with like just a little wire that's run through it, and then it's totally open. We also want to seal our core walls to our floor slab, seal our crawl spaces, as well as exterior doors. We also need to seal vertical shafts. Larger buildings especially tend to have large vertical shafts moving up and down through the building that are great air leakage pathways. and lead to increased stack effect. So those include stairways, fire hose cabinets, plumbing chases like the one that we saw with the insulation, as well as trash chutes. Whoa, so leaky trash chutes. We need to seal the doors and also seal those floor to floor so we don't just have a big around the trash chute itself. Obviously the trash chute, inside the trash chute will be open, but the sort of surrounding area that it's in, you want to seal that at each floor to reduce air leakage. We also want to seal our outside walls and openings, which means weather stripping all windows and doors, sealing all surface penetrations and electric receptacles on any outside walls. So there's a lot of stuff to do for air sealing, and air sealing is really, really important. And so this is not an air sealing webinar, but so we'll move on from there. But there's lots to do for air sealing, particularly in existing buildings. So in terms of insulation, there are a few different types of insulation materials that are common in multifamily buildings. Fiberglass, very common. Cellulose, also pretty common, depending on what the application is or the location. We're increasingly seeing projects, particularly for exterior continuous insulation, moving to rock wool or rock wool boards because it's very fire resistant. And it has lower global warming potential than, or I'm sorry, lower embodied carbon than foam boards like you see in the bottom left. So polystyrene, either extruded or expanded polystyrene can be used for wall or oftentimes roof insulation, rigid insulation on roofs. Polyurethane spray foam can be used in certain applications, and then more expensive but effective for very specialty applications can be aerogel. So major insulation opportunities in multifamily buildings, attics, crawl spaces, garage ceilings, particularly in multifamily. We often have parking on the ground floor and then units above that parking. And so we just have like a big uninsulated concrete slab. And so it can be very effective to insulate those garage ceilings with units above them, as well as any exterior walls. You can insulate uninsulated exterior walls on existing buildings. You don't have to rip everything off. You can drill and fill and blow in cellulose or blown fiberglass. And so we want to make sure that our entire building on all sides is well insulated in addition to being air sealed. Okay, so that's air sealing, insulation. We touched on windows. We're going to move right along to ventilation. I'm not sure what other people's experience has been with multifamily ventilation systems, but in our experience, multifamily buildings are all over the place in terms of ventilation. They're underventilated, they're overventilated, they're often erratically ventilated, they're intermittently ventilated. Sometimes it's on, sometimes it's off. Flow rates are all over the place, and they just really frequently, the systems don't work, particularly in existing buildings. So how do we fix this? What we do is air sealing and controlled ventilation. Hopefully, everyone on the call is an experienced building professional and has heard the phrase build tight, ventilate right. That is what we want to do. We don't want to just say, well, our building's leaky, so that's our ventilation, right? Or you know, people have this misconception that buildings need to breathe. The ventilation system, that is the lungs of your building. It is doing that breathing. We need to air seal and then ventilate effectively. So we want to reduce uncontrolled infiltration and exfiltration via leakage, which we mentioned. We want to use our ventilation system to bring in the right amount of air and remove the right amount of air. And we want to ensure we have uniform and balanced flows from apartment to apartment. And that'll typically allow us to decrease overall flow rates. So reasons that a system might be imbalanced. You could have taped up grills due to smell transmission from other apartments, or even bugs coming in, yuck. Grills might be covered by furniture. You could also have duct leakage or dirt. This is a great example in this photo of the type of thing we see pretty frequently in existing buildings. You just have dirt that's clogging it up. Are they getting much ventilation through this? Probably not. So duct leakage is super crucial. On the left, you can see an image of the termination point between a horizontal runout of an exhaust duct and the sheetrock. And on the right, we have a vertical riser that's meeting the roof. You're looking down into the riser. And for both of these, we have huge areas where the duct is just totally disconnected from the shaft around it. And this can represent up to 50% leakage in your duct system. You're not actually, the fan that's on top of this is not actually ventilating the unit or the building effectively, it's ventilating the wall cavity. And this is a huge deal. So ensuring that our ducts are not leaky will go a long way to delivering effective ventilation. So from ventilation, we're going to move on to heating. Heating systems in terms of their operations and maintenance. If we have electric baseboards, there's not a whole lot of operations and maintenance. That's part of why people really like them, because they're easy and pretty idiot-proof. If we have ducted systems, we do need to pay attention to duct sealing, cleaning, and insulation of our ducts. If we have gas or propane or other fossil fuel-based systems, we have combustion safety requirements that we need to make sure we're meeting. And then central steam and hydronic systems tend to be in larger or older buildings. There are lots of O&M opportunities around pumps, air vents, steam traps, outdoor reset controls, etc. We're not going to go into those, but just know that they are there. If we have combustion equipment, we need to ensure that all of those appliances are tested based on applicable standards, such as the National Fire Prevention, I don't remember what NFPA is, but it's National Fire Organization. BPI, or Buildings Performance Institute. We need to verify that carbon monoxide detectors are installed per code, and the type of testing you do on these can include things like testing for gas leaks, testing for spillage, carbon monoxide, combustion efficiency, and draft. And we will talk more about these in the health and safety webinar. So cooling systems. Cooling system types, broadly speaking, there are a lot of them, but broadly speaking, you might have a ducted system or a ductless system. You could have room-by-room systems with a cooling unit in each room, or you could have a central system that's ducted to all of the rooms. And then most systems all cooling systems use some form of refrigerant, but for some systems, they actually are moving the refrigerant around the building, and others, they may be using chilled water and moving chilled water around the building to deliver to various spaces. So on the upper right, just in terms of the photos we're looking at, on the upper right, we have a package terminal air conditioner. In the middle right, we have a ductless mini split heat pump or air conditioner. And in the bottom right, we have a variable refrigerant flow system, which is like a central heat pump system that does heating and cooling and delivers heating and cooling to multiple units like this one here, scattered throughout the building. And then these big rooftop units handle lots of indoor units. So O&M opportunities for cooling systems are many. Refrigerant charge and leakage testing is really important to ensure that our system is properly charged and can operate effectively and efficiently. A refrigerant is really like a Goldilocks situation. You don't want too much and you don't want too little. You want just the right amount of refrigerant, and that's how your system is going to perform its best. If we have ducted systems, we need to ensure that we have proper airflow. This is another Goldilocks type of situation. Too much airflow or too little airflow, you could either get not enough cooling or you could get not enough dehumidification. And so you need to have a balance of both. If we have condensate drains, we need to ensure that those are maintained and not leaking. If we have outdoor condensers, we need to clean them properly, replace filters on systems with filters, and evaluate ductwork and ensure that our thermostats are all calibrated. So that's cooling. I'm just going to pause briefly. Any questions thus far on our systems?
Yes, I'll pause if we have any other questions. We have one question on the ventilation and air leakage, and that was related to understand ventilation and air leakage. It often requires blower door testing or duct leakage testing, which can be costly in multifamily buildings. Is that level of testing necessary, or are visual inspections enough?
Yeah, so if we go back to that slide, I mean, you can look at this. If you pop the fan off, in this case of the roof, or you pop the register off of the wall in this case, a visual inspection would be sufficient for you to say, oh my Lord, I probably have a really leaky system. And then come in here and seal this duct. And same here to say, oh my goodness, this is probably super leaky, and seal this up. So you can absolutely gain a lot of information and make a lot of improvements just based on visual inspection. To take it to the next level, of course, you do need to do things like duct blasters, and blower door testing is more for the whole building than necessarily for the ventilation system itself. But you can learn a lot from a visual inspection, absolutely.
Thanks. And then one other question we had on air leakage. So if you have a very leaky building, what's the best place to focus on that's most cost effective and to get the highest energy savings?
You know, it really depends, because it basically focus on wherever the biggest leaks are. And it's going to vary by building. The order that I presented things in, sealing the top of the building, and then sealing the bottom of the building, and then sealing vertical shafts, and then sealing the sides of the building, that's like a general approach, because particularly in heating dominated climates, a lot of leakage tends to happen at the top of the building. But that being said, if you might have a building where the top and bottom are super tight and you have giant leaks in your walls, and so for you it might make the most sense to test or to do air sealing activities in the walls. So I think sort of start with, it helps to start with a prescriptive list of like, are all of our doors air sealed? Are they well gasketed? Can I see daylight from inside? If I can, I definitely have a door that's leaky. And sort of the hard answer, the truth is just that there's no one place to start because it's going to depend on what you have at your building. So I wish I had a better answer than that, but the truth is it depends.
Okay, really good.
Great, thanks. Well, that's all we have for questions.
Okay, so moving on to domestic hot water. We have a lot of different types of domestic hot water systems. You might have a gas-based water heating system. You could have electric resistance-based water heating systems, or increasingly, we're seeing folks move to electric heat pump-based systems, which are the most efficient, type of water heating system you can use. So opportunities for operations and maintenance on these systems. All system types, you can insulate pipes and tanks. You can lower the delivery temperature of your hot water. You don't need to, and you should not be sending out water that is ultra hot, right? People might get burned, and you'll use less energy if you send it out at a lower temperature. Low flow fixtures, repairing leaks, verifying control set points and recirculation controls, ensuring that your tanks are descaled and your anode rods are replaced regularly. Also, don't store corrosives near your water heaters or near your tanks, because they can release fumes that can degrade equipment. For gas-based systems, you want to do those combustion safety tests and also make sure that any motorized dampers are working. If you have electric heat pump water heating systems, you'll need to clean the evaporator coil just like you would for an air conditioner if it's accessible, and then occasionally you'll need to service the compressor as needed. For lighting, in terms of lighting technologies, these days most things folks are installing are based on LEDs. We might still have some high intensity discharge lamps out there, like high pressure sodium or others. There are also plenty of fluorescent lights out in the world, are linear or compact fluorescents. And then occasionally you might come across an incandescent bulb or two. These are going by the wayside, and kids being born today will grow up in a world that is mostly devoid of incandescent light bulbs, and that might make some of us sad, but it's ultimately good for the planet. So opportunities for lighting systems. You can upgrade your fixtures or your bulbs to LED. You can install shutoff controls like vacancy sensors, time clocks, or photo cells. Other controls like occupancy-based dimming or daylight controls can be really helpful, as well as just tenant education and reducing any overlighting. So a lot of older buildings, well, some older buildings are underlit, others are overlit. And so if you have a space that is really overlit, are there sort of low-cost ways that you can reduce overlighting and save energy that way without having to make a costly upgrade? For appliances, opportunities are we can upgrade to Energy Star appliances. For refrigerators, we want to keep the coils clean, keep freezers full, maintain the gaskets on our refrigerators and freezers, and then defrost the freezers if we get frost in them. If we have vending machines, we can install occupancy sensors on them. Water coolers like you have in offices, just a basic timer is really effective to turn it off at night. If you can have a 7-day timer, turn it off on Saturdays and Sundays when people aren't there. Clothes washers, make sure we have front-loading clothes washers instead of top loaders, as we use a lot less water and energy. And then for appliances, we want to ensure that any appliances we remove are being properly recycled. This may be a requirement of the program you're participating in or of the particular jurisdiction that you're in, but we do want to make sure that any appliances that are being removed or any other materials in our building are being disposed of and recycled if possible. Water. People often get to water last, but water is really important. And as energy usage decreases, water becomes sort of a larger piece of the pie in terms of the resource consumption of our buildings. The first thing for water conservation is to fix leaks. Fixing leaks can go a long way to reducing water waste. Common leak sources are toilets, shower diverter valves, landscaping, and really anywhere else you see a leak. But toilets, shower diverter valves, and landscape are places that often have really significant leaks. From there, we can install low flow fixtures like shower heads, aerators, toilets, dishwashers, and laundry equipment that's water efficient. For our landscaping, we can use low water or native landscaping, smart irrigation controls that sense soil moisture or know if it's rained recently, or we can even use rainwater capture to reduce the amount of potable water we have to use to irrigate. And if we want to reuse water, that's great if we can work it into our project. We can use rainwater, gray water. A lot of projects do laundry to landscape. That's pretty common. And then others choose to go sort of even further with like gray water and black water treatment on site, but that's not as common in existing buildings. So to wrap things up, energy efficient operations and maintenance can help lower operational costs and extend equipment life. It can improve tenant comfort and reduce complaints. And that's really sort of why we want to do this, because it's ultimately good for us as building operators. Maintenance practices should be preventative rather than reactive. And energy efficiency is most effective, and we get the most out of it when personnel is trained and understands how these systems work, and an organization commits to ongoing training of building operations staff. And being on this webinar is part of that commitment. So I just want to thank everybody for your time, and then open it up to any final questions that we have.
Great, thank you, Nick. So as a reminder, if you have any questions, you can enter them into the questions box. And also, we can also open the audio line at this point. If you want to ask a question directly, you can raise your hand. So we had a couple of questions. One is, do you have any recommended resources or templates for starting a management plan?
That is a great question. I don't have an answer to that off the top of my head, but I know they're out there, and I can find some, and I will send it to Mecca, and Mecca can send it on to the group. Would that work?
Yeah, that's perfect. And we can post it along on the website with this training. Perfect. And then
it was for an O&M plan?
Yes. Just generally a management plan, an operations and management plan.
Okay. Yep. Sure.
And then the other question is, since occupants have such a big impact in multifamily buildings, are there any aspects of the management plan that should involve the tenants or tenant education?
Yeah, this is a great question. So it kind of goes both ways. Like, we can engage with tenants and ensure that I think on the most fundamental level, if you have a building, particularly a new building, that's installing systems that may be different from what is typical in multifamily buildings in your area, and therefore tenants who move in are likely to be like, what's this thing? Then I think tenant education is really important. But I also think that as we're thinking about what types of systems we want in our building, we have to, be cognizant of the fact that people are going to move in and out of these buildings. And so to the greatest extent possible, it can be really helpful to have systems that are kind of tenant proof, where like you don't have to understand how to operate it. It just does it itself. So like, I think we need to sort of focus on both sides. How can we make the systems in the building simple so people don't need to be educated, or they can operate it just like they are used to doing things. Like, for example, LED lighting. They don't operate an LED light any different than they did an incandescent light. They flip the switch, they turn the dimmer up and down. It works the same, and so there's no education that needs to happen. But for, like, let's say a heating or cooling system, or let's say a super efficient heat recovery ventilation system, that might be different. And so to get the full efficiency out of those systems, you might need some tenant education. So it really depends on the system, but I think we can sort of help ourselves by thinking about, like, can we install something that's efficient but also simple, so that, you know, every time a new person moves in, we don't have to worry about, okay, we got to explain this thing to them because it's weird and they won't know how to work it.
Okay, great. So that looks like all the questions we have. I don't see any coming through right now. So I think we can conclude there. So thank you, Nick, for this great presentation. For those of you on the call, if you have any questions on the program or follow-ups on this training, you can contact us at this email address or on our website. And thank you all for joining, and have a great day.